Hey guys, and thanks for tuning into my new tutorial series on making a soccer game using Blender and Unity. I've moved my upload date to Wednesday in the hopes that I can please this female dog of a YouTube algorithm. If you enjoyed this video, please don't forget to like it, and also subscribe to see more in this series and more content like this. I'd appreciate it if you did subscribe. Just remember you can always unsubscribe later if I become boring or inactive. It's free, so why not? So to be honest with you guys, in the short period of time that I've been on YouTube, I feel like I've locked myself into a corner on creating certain kinds of content. I really want to avoid that, so I can just keep creating great content for you guys. I want to make sure that I still find game development enjoyable, as well as I'm continuously improving my abilities in it. So this week, we're going to try something a little wacky. When I was a kid, I loved going on these virus-ridden websites like Addicting Games and the not-so-safe-for-school Newgrounds.com. I loved playing the simple Flash games, but going back there recently, it looks like a lot of the classic games that I used to play have become inaccessible. I can't even find them anymore. So my brother requested that I make Slime Soccer, which is a little soccer Flash game where two slimes play soccer. Simple enough. I thought I could make this game, so I did exactly what I knew to do when it comes to game dev. I looked up a tutorial on how to make a soccer game in Unity. And I found that no one has any soccer tutorials that are up to date. So I just decided to make some characters in Blender and develop it until I legitimately got stuck. So, for you guys, this is probably one of the only modern Unity soccer tutorials on YouTube. So I'm sorry for that. Maybe we can push some kind of ball and get some people that actually know what they're talking about to make a soccer game. Hopefully you enjoy this series. It's a couple parts and we can kind of create a soccer game together. This is going to be a different format from my normal videos. Making a lot of tutorials and I'm going to release them pretty fast. So subscribe to tune into this series and give these videos a thumbs up if they provide you any value. Also check the playlist. Thanks. Bye. Hey guys, thanks for watching. Make sure to like and subscribe and let's just jump right in. And to begin, I'm just going to show some of the assets I created in Blender. I'll leave them available to download in the description below so you guys can follow along. First I made the ball. I just applied a subdividing surface modifier 2 times to the default cube and then applied smoothing to it. This is the jelly, the slime that we're going to be using. I colored him blue and made him a little slimy. Now when it's in real rendered mode, it doesn't look as slimy. We could probably fix that at some point. I mean if we have to. It looks nice to me. I like how simple it was to make these guys. This is the goal that I made. Very simple, mostly cylinders. The hardest part was making the net. But I actually found a really good tutorial for that. It was how to make a net on Blender. It was by the Blender master, Green Pillow. I've included the link to his video in the description below, so check out if you're interested in learning how to make a net. You can download the assets in the description below. What we're doing first is starting off with an empty Unity project, and then we're going to start doing what we do best, programming the game. The first things first, I'm going to make the ground and line it up with the camera. We want to make sure we have a good angle on the ground. This game's going to be a 2D game with 3D assets, so it's an interesting style to say the least. Most of it isn't difficult, it's pretty straightforward and some good practice. It's nothing like FIFA. It's going to be pretty close. So I'm just expanding out the ground a little bit, bringing it down and making sure it's level with everything. Next, I'll create a folder for the Blender files and pop them all into the Unity editor. You don't even have to export them as FBXs if you don't want to. The cool thing about Blender is if you want to import it directly into Unity, pretty good at supporting Blender files. Now, exporting to FBX is probably a good idea. I mean, exporting anything is good. But using the Blender files, especially for animations, is a great alternative to FBXs. Now let's make our slime character. First things first, let's make an empty game object and call it player. Make sure it's zeroed out so it's not messy. And then we'll pop the slime in there and make sure he's zeroed out. Then we're going to rotate the actual slime model, not the player object, -90 or 270 on the Y. -90 is the same as 270. And now using the player object, we're going to create a player controller. There are actually 2 prominent ways to go about creating a character controller. There's rigid body and character controller. Now I'm going to use the character controller method because I feel like it would work better in this soccer game. The thing about character controller though, is that it doesn't have any physics. So we're going to have to create scripts for everything. The first script we'll make is the player motor script, which will handle the movement and the gravity of our player. Now just because our player doesn't have a rigid body doesn't mean nothing can have a rigid body. we'll cover that later. So first, let's do the player motor script. We'll drag it onto our player, and we're going to open in Visual Studio. Once we're in, the first thing I like to do is erase everything out. Let's get a clean slate here. We're going to have to declare some variables. First, I'm going to declare a variable. We have to access that character controller, so I'm going to put private character controller. And then with private variables, it's standard to use underscores. So I'm going to call it underscore controller, just to tell the difference quickly between a private and a public variable. Next, I'll create a serialized private float for move speed. We'll set equal to 10. And then next variable will be a private vector3. We'll call it move. Just to be sure, if you're following my style, all of these private variables have an underscore. Simple enough. Now we're going to call the start function and activate our controller. Controller, get component, character controller. Not too hard. Then we'll go to the update function, and that's where we'll handle our direction finding. First, I'm going to create a float called horizontal, and then I'm going to use the input of the raw horizontal movement. That's basically just the A and D keys, or the left and right keys, to calculate the movement. And then I'm going to set the vector3 move, the equal of vector3 with horizontal as the x, and 0 and 0 for the y and z. Since basically it's a 2D game, we're just going to be using x and y for our calculations. Now to simplify this, I'm just going to pop this in its own function, and I'm going to make a return of vector3, and we'll call it calculate movement. So basically I'm going to have the calculations happen here, and then it's going to return the value of move. So this is just a helper function. It's good practice to keep everything organized, and I also think it's good practice to create return functions that aren't just void all the time. It's good to understand what other functions do besides just the void functions. Next, I'm going to do the movement here. I'll use controller.move and pass in our move vector3 and multiply it by move speed and time.delta time. The reason I'm doing the late update function is because it's called right after the update function. It's kind of like an order of operations thing. So we're calculating the movement first, and then we'll do the controller.move. So it's stricter for the update. And so now, let's test it out. And there we go. We have our player moving. The speed is good. And now just to keep our update functions organized, I'm going to take this controller.move and put it in its own little function called move. And that's all for this video. Check out the next one where we'll handle the ground check for our character. Make sure you like and subscribe, and thanks for watching. Bye. Hey guys, thanks for watching. Make sure to like and subscribe, and let's jump right in. For this video, we're going to add a ground check to our character so that we can tell if he's grounded, which is going to be a fundamental thing to add jumping into the game. It avoids the issue of jump spamming. So the first thing I'm going to do is add a public float called ground distance, which we're going to use to calculate a sphere around the ground check object that we create. Then I'm going to need a transform of the ground check object that we're going to create, and a layer mask to tell us which layer the ground is on. I'm making these public because it's easy to edit them in the Unity window, and it's not a huge deal if other scripts can access them this early on in the game. I'm also going to create a private bool called isGrounded, and don't forget the underscore for the private variables. Next, in the update function, we're going to check if we're grounded. We're going to use physics.checkSphere, which creates a little sphere around an object. So for that we need a position, which we chose the transform, so pop in groundCheck.position. Next, we need a float to determine the size of the sphere, so put in our ground distance, and then the ground mask to tell the function which layer is on the ground. So basically, we're grounded if our sphere is touching the ground. Now let's create that ground check object. Create an empty game object under your player. We'll rename it ground check. Let me fix this capsule collider a little bit to fit our character. Kind of just messing with me here. You can get it just right. Just making it a little taller and making the radius a little wider because our character isn't really the regular T-pose humanoid. Not the biggest deal, it's just a little soccer game. Now I'm going to position the ground check to right below our character's capsule collider. And then we drag the object into the ground check transform on the script. Next, we have to set our ground to the ground layer. It's easy to create. Just add a new layer, call it ground, and then go to the ground object and set it to that layer. Once that's done, go back to the player and set the ground mask to ground. So now, if we're touching the ground, we're grounded. And you can verify this in debug mode. It's actually showing that we're grounded while we're floating, so what's going on is that I think the ground distance sphere is a little too big. All we have to do is make it smaller, and you can see the smaller it gets, the grounded goes away. 0.6 is a little big. We don't want to be grounded while we're floating. So what we can do is fine tune it in the editor. 0.5 looks good to me for now. I like to change it in the script too, just in case something messes up. So just for extra organizational skills, let's create a function that returns a bool called ground check. Very simply, I'm just going to take our isGrounded check and return that in the function. So if this is true, isGrounded will be set to true, and vice versa. It's a good one-line function and great practice for return functions. Then I'll just replace where it was in the update function with the ground check function. Now I'll just prep the script for gravity and jumping, which is going to be the next video. We'll create a serialized private flow for gravity, and we'll set it to -20. It's negative because gravity pushes us down. Easy way to remember. Next, a serialized private flow for jump height, and I'll set that to 3. Jump height is positive, we go up. Finally, a private vector 3 for velocity, which will measure our y, or our up and down velocity. And that's all for this video. Make sure to like and subscribe and check out the next one where we'll handle the physics for our characters. Thanks, bye. Hey guys, thanks for watching. Make sure to like and subscribe and let's jump right in. So last video we did the ground check and now I'm just cleaning up my move calculation. It looks nicer to me without the new vector 3 blah blah blah. I like seeing some simple multiplication. It's like multiplying our horizontal input by 1, 0, 0. That's exactly the same thing. Now, let's do something about our gravity. I'm going to create a void function called apply gravity. And there's a simple formula to apply gravity that I learned from Brackeys, who I hope is having a great time now he's away from YouTube. We just add gravity times time.delta time to our y velocity. And then, to make it apply, we use controller.move with our velocity times time.delta time. And we can also move the ground check from the update function to the gravity function. My main goal with this is to keep update as clean as possible. The big thing is we don't want gravity constantly increasing if we're grounded, so we'll create an if statement. So if is grounded and our velocity is less than or equal to 0, then we'll make it equal to -2, which should keep us on the ground and make sure we don't wind up floating by accident if the ground check hits too soon. Next, we'll pop the apply gravity in the update function. And let's make the jump function, which is pretty straightforward. If I push the jump button and is grounded, then we want to jump. So in order to jump, we need to make our y velocity a positive value. So we just set it equal to the square root of our jump height times -2 times our gravity. This will be positive because we're multiplying two negatives, the gravity and the -2. Alright, done with that. Let's test it out and... it's not working. What's up with that? We can't jump. What's going on? Oh, I forgot to call jump in the late update function. Okay, and now back to testing. And there's gravity. And now when we push space, we jump. It's a little floaty. We just have to fine tune our ground distance. We need it small, so let's try 0.1. And there we go, some real falling. Real quick before we finish, I'm going to create a prefabs folder and save our player as a prefab to save our settings. And that's all for this video. Make sure to like and subscribe and check out the next one where we'll handle the physics for our ball. Hey guys, thanks for watching. Make sure to like and subscribe and let's jump right in. So for this video we're going to create a soccer ball and add some force to it. We're going to try to get it feeling like a real life soccer ball. So first, let's drag in our soccer ball model. The texture didn't drag over, so you might as well just use a sphere in Unity. It'd probably be nicer anyway. We're just going to take the ball and adjust the size to make it soccer ball size. And then we're going to add a rigid body to it, and this will add the gravity and some functions that we want to the ball. This is what I was talking about when I was utilizing the character controller and rigid body together. Next, if you didn't add the sphere from Unity, we're going to add a sphere collider to the ball so it can bounce around and not just fall through the floor. So let's push play and see what we've got in. It doesn't bounce. It just slams into the ground. And it won't roll, it's more of a step. So we have to fix that. What I think we should do is first we need to make it look nice and make sure it bounces. So we need to create a material with the texture of a soccer ball, and next we'll create a physics material and we'll call it bouncy ball. Let's change the settings of the physics material. The dynamic and static frictions we can set to 0, and the bounciness to 0.95. We don't want it to be 1 because the bouncing will stay constant. 0.95 gives it a real kind of soccer ball bounce. Alright, so let's drag that material onto the ball and voila, it bounces. Still a stepping stone though, so we've got to get beyond that. Before that though, let's get this looking like a soccer ball. I have this soccer ball texture that I got from Google, and it should be fine. It doesn't look exactly like a soccer ball, but you'll get the gist of it. Pop the texture in the albedo, and I'm not going for extreme detail. If we were, you could make a normal map of the ball and give it some real texture. I'm just going to adjust the tiling a little bit, because it looks a little freaky like this. Some kind of space soccer ball. There we go. That looks close enough. let's just change the Y tiling. Alright, and we have a Star Wars soccer ball. So if we just adjust the offset, and you can adjust the settings to get it wherever you like. Me, I like it like this. It looks fine. So a little bit more fine tuning just to make the good round numbers. And there we go. Looks good to me. Kind of soccery. Now I'm just going to change the smoothness and metallicness. You can adjust everything to whatever makes it seem realistic enough for you. And I like this. Before we create the ball script, let's just organize everything a little bit. We're going to put the textures in a texture folder, materials in a material folder, and the physical materials in the... you get it. Now to get the ball reactive, we're going to create a box collider on the front of our character. We're going to make it the size of our character so we can steamroll the ball instead of stepping over it like it's a stair. Don't forget to freeze the ball's Z rotation and position since we're doing a 2D style game here. And if we test it, you see it's pushing. We don't step over it. But it's still not acting like a real ball. So what we need to do is create a script for it. Let's call it ball movement. Drag it onto the ball and open it in Visual Studio. I'm going to clear everything out of here and create a private transform, and we'll call it hitter. Don't forget the underscore. This is going to be the person hitting the ball. Next, we'll check the ball's on collision enter. A quick if collision.collider compare tag is player. Then we're going to set the hitter equal to this character. Then we'll check the same thing for on collision exit. If it's the player, then we'll set the hitter equal to null. And now we're going to create a method called add force. We're going to take the difference of the position of the character and the position of the ball and add an opposite force to the ball. So first we need a vector 3. I'm going to call it distance. And we'll set that equal to the position of the hitter minus the position of the ball. Now let's make a private rigid body to add force to the ball. We'll do rigid body.add force, and then we'll pass in a vector 3. So let's do negative distance since we want the opposite, times time.delta time times 10 to make it a little greater, 10 exit. Now let's change those comments. So let's set hitter equal to collision transform in the enter, and then on the exit let's set hitter equal to null. In the update function, let's call add force, and a little adjustment. In the add force method, let's do if hitter is not equal to null, so we'll only call what's inside if there is a hitter. So let's test this out a bit. Dang, it's still stepping over it. Not really working. Something's going wrong. Let's check out the code. Okay, so we forgot to instantiate the rigid body. So let's call the start function and set rigid body equal to get component rigid body and test it again. And it looks better. Like, we're definitely dribbling the ball. We're adding a little force, but not enough. Let's check debug mode to make sure the hitter is actually registering. I mean, yeah, we have the hitter. It is pushing the ball. The problem is that the amount of force is a little bit too small. So let's get rid of the time.delta time and voila, it works. And that's all for this video. So make sure to like and subscribe and check out the next one where we'll handle the scoring system. Thanks. Bye. Hey guys, thanks for watching. Make sure to like and subscribe and let's jump right in. So in this video we're going to try to add a little scorekeeping system, which shouldn't be very hard. We should be able to do this relatively quickly. First thing I want to do is save the soccer ball as a prefab. That'll just ensure any settings that we have on the ball, the rigid body, the collider, and any additional scripts will be saved in that object. Now, we'll go back to the Blender files and we're going to add the goal. Let's pop that in position and make it look like a real soccer goal. A quick 90-degree rotation on the Y-axis. Right now we're just doing one side and then eventually we'll add the second side. So we're just going to position this right. Alright, line it up with the edge and perfect. Next, I'll create a cube and pop it inside the goal. We can use that box collider as the trigger. Basically, we want the trigger in the goal. So if the ball hits the goal, we get a point. And I want it to be thin but well-fitting, so if it goes to the front, it's a point, but if it goes to the back, it's not. Don't forget to set the collider to trigger, and then delete the mesh renderer and mesh filter from the cube so we don't see it anymore. I'm also going to rename the trigger Goal Trigger. And then I'm going to add some tags to the goals. I'll call the first one player goal/P1, and then another tag called player goal/P2. We're going to keep things relatively organized here. So, we could add the tag to the actual goal, but it won't do anything. We really want to add the tag to the specific trigger so we can access it directly. Next, I'll create a new C# script and call it Score Manager. We'll open that up and clear it out. And then I'm going to declare it a singleton, so we can easily access the public variables and methods in this script from any other script. You can use the hashtag region and nRegin to create a collapsible area in your script. So now we do public static score manager instance, and then awake where instance equals this. So now we can access the public specifics of this instance from anywhere. Very useful. Next, we'll set the scores as static variables. Public static int p1 score, we'll set it to 0, and the same for p2 score. Next, I'll create another script called score, and we'll attach this one to the ball. But first, let's quickly create a game manager object and pop the score manager script on there. Move it to the top for organizational purposes, and now let's open up the score script. We'll clear it, and then we'll add an on trigger enter. So if other.compare tag is player goal /p1, then we want to add a point, so score manager.p1 score ++. And then to test it, we'll add a debug.log p1 score to p2 score. Add the score manager in front of them, and then we'll just destroy the ball. And actually, to make this even simpler, every goal I'm going to reset the scene. So let's go back to the score manager script, and at the top, import unityengine.sceneManagement. And we'll create a method called resetPositions. In it, we'll call sceneManager.loadScene, and then we'll load sceneManager.getActiveScene.buildIndex. And that should reload the scene every single time we get a goal. Now go back to score, and we'll call public score manager. And in the start method, we'll set it equal to scoreManager.instance, which will cache the singleton. And after we destroy the ball, we'll call scoreManager.resetPositions, and then just copy that for P2, change all the pertinent stuff. Now let's test it out, and every time we get in the goal, there we go. It destroys the ball, and if you look at the console, we're actually getting points here, so it's working. And that's all for this video. Make sure to like and subscribe, and check out the next one where we handle spawning the ball and creating some bounds. Thanks. Bye. Hey guys, thanks for watching. Make sure to like and subscribe, and let's jump right in. So in this video, we're going to create a spawn point for the ball so we can learn how to spawn things on start, and then we'll also create some invisible boundaries so that the ball won't keep bouncing out of bounds. So first things first, let's create an empty game object we can use as a point to spawn our ball, and then let's create a script to spawn the ball. We'll call it Spawn Manager, and let's pop it on the game manager object. Once it's open, I'm going to clear it out and declare a public transform soccer ball spawn. Then we're going to use the start method, so type start. And then we also need a public game object soccer ball. So on start, we'll just instantiate the soccer ball in the soccer ball spawn.position, and then use quaternion.identity to use the soccer ball's default rotation on spawn. Let's just go to the game manager and drag the soccer ball spawn into the transform. Delete the in-game soccer ball, and drag the soccer ball prefab into the game object slot. And now, like magic, when we push start, the soccer ball will drop out of the sky. And just for your information, this is a way to spawn anything. Not just in this game, but any games can use similar mechanics, so feel free to extrapolate this knowledge to any project. One more thing is that when we kick the ball out of bounds, we don't want it flying away forever. We want the game to keep going, so let's create a wall. I'm going to make a cube and I'll stretch it out, create a little wall on the edge. I like the wall, but I don't want it to be so dauntingly huge, so let's just delete the mesh renderer and the mesh filter. Voila, we have an invisible wall. I'm going to call this one P1 invisible wall, and then we'll copy this over and make it P2 invisible wall. And there we go, we have a nice ball spawner and some invisible boundaries. That's all for this video. Make sure to like and subscribe, and check out the next one where we'll handle the scorekeeping UI text. Thanks. Bye. Hey guys, thanks for watching this video. Make sure to like and subscribe, and let's jump right in. So in this video, we're going to create some UI text for our scoring system. We're just going to display our score at the top. First things first, let's create a new TextMesh Pro object. And for that, we're going to have to import TextMesh Pro. What TextMesh Pro does better than any regular UI text is that it retains its high quality even when it's scaled up. You can have it scaled as big as you want, and it'll maintain great resolution. Now I'm going to go to the anchor point and alt-click and hit the top left corner. This will move our anchor point for the text to the top. Then, to make the dimensions fit the whole screen, I'll shift-click the blue arrows on the bottom right. Now, if we go to the left, we want it to be placed in the middle. So if you're creating in 1920 by 1080 resolution, I'll set the position to 1920 divided by 2, which will put it in the middle, and then offset it by 200, so minus 200. Then, I'll duplicate it, and move the other one plus 200 back to the center, and then plus 200 for the offset. And there we go, some visually appealing, evenly spaced scores. So now, let's go to the Score Manager script. Let's add some UI function. First things first, we'll import TextMesh Pro, so type using TM Pro at the top. Then we'll declare a public TextMesh Pro UGUI variable, P1 score text, which will allow us to edit TextMesh Pro text. And then we'll copy that for P2. Easy. So now, in the update function, we're going to constantly be checking for the score. P1 score text.text equals P1 score dot to string, because it has to be a string. And since that's a method, let's include some parentheses. And that'll make the score appear. So copy P1 and change everything to P2. Now let's create a little test. If I push T, then P1 score will go up. And then if I push R, P2 score will rise. It's a good way to test it. So now, just drag the UI onto the script, push play, and there we go. Looks like it's updating. Ladies and gentlemen, we have ourselves a score system. And that's all for this video. Make sure to like and subscribe and check out the next one, our last one, where we'll handle a second player input. This has been an excellent journey. Thanks. Bye. Hey guys, and thanks for watching. Make sure to like and subscribe and let's jump right in. So in this video, we're going to add a second player and a system to control him. We're going to do it in this traditional slime soccer way, so 2 players on 1 computer. First thing I'm going to do is make all the individual game objects into prefabs. This includes the goal, the ball spawn, even the game manager object. In order to create the player 2 goal, we just have to duplicate the player 1 goal and reposition it across the field. Then, just rename it P2 goal, and make sure you tag the trigger correctly as P2 goal, and then we'll prefab the P2 goal to make it save in the settings. And now if I push play and get into that goal, there should be a difference, and whoops, the character has a push collider on the front but not on the back. So what I'm going to do is I'm going to copy the collider on the character, and then paste another one as new, and just move it over on the x-axis to the other side of the character. Now a little test, and once it catches, there we go. We can attack, we can defend, we can all make the same mistake of slamming our ball into our own goal. Just like real soccer. Make sure you update the player prefab so he has double colliders. I'm going to rename this one player 2, then I'll duplicate him and call the other one player 1, just because of the sides that they're on. I'm going to maneuver player 1 to the other side of the field, and rotate the actual character 180 degrees. Give it a test and boom! We have some synchronized jellies. Kinda reminds me of foosball. I'm still used to this guy being my guy, so even when I'm playing both, when I make it into that other goal, I still feel lame. Now, let's try to get these controls working. For me, this is complicated, because one little typo or wrong setting can have you scratching your head for like an hour. So first things first, let's go to Edit, Project Settings, and then Input. For organizational purposes, I'm going to turn this first horizontal into P1 horizontal, and then make the primary left and right keys A and D. I'll remove the left and right. Negative means that the value will be negative. Like on a normal graph, negative is left on the x-axis and right is positive. For P2, go to the next horizontal and change it to P2 horizontal. And what we want to do is use left for negative and right for positive. Just a quick change while we're in here, I'm going to go to the Physics tab and change it to about -13. That'll just reduce that floaty effect. Then we have to adapt the player controller script to include P1 or P2 movements. First I'll make a bool testing if is player 1 is true, and if we are, then apply the player 1 controls, and if not, we'll apply the player 2 controls. In order to flag the character as player 1, we're going to add a layer mask in a similar fashion to how we added the tags in the goals before. I'll call one player/player 1, and the other player/player 2, and then we'll apply them respectively to the characters. Make sure when you switch layers, you apply it to the children as well. In order to see if it's on the player 1 layer, we'll do a check. If this.gameObject.layer is equal to the layer mask.nameToLayer, and then a string player/player 1, then is player 1 is true. And just as a failsafe, in the else we'll add a false, is player 1 is false. Now let's go to calculate movement and set up separate controls for player 1 and player 2. Then put all the code in there, change the horizontal axis to P1 horizontal, then else, same code but P2 horizontal. We don't really want to repeat ourselves, so we could actually move that return statement out of the nest since it returns the same value either way. Now we'll do the same thing for jump. If player 1 it's P1 jump, and for player 2 the same thing, P2 jump. Then, in our input, let's add P1 and P2 jumps. And when we test, of course it doesn't work. We have a small issue, and it's really hard to figure out. It all falls back in the input settings. P2 horizontal is set to joystick axis when it should actually be set to key or mouse button. And then beyond that, we want to match the input settings to match the P1 horizontal, so there's no lag. Everything's the same. And there we have it. Slime Soccer. It's fun and ready to play. And that's it for this video. Make sure to like and subscribe. This is the final video of the soccer series, so I hope you enjoyed it and are ready for whatever videos will come in the future. Thanks. Bye.